Okay, let's do the algebraic interpretation of the instantaneous rate of change. Here's a typical example. I have to determine the instantaneous rate of change at this particular function y equals negative x squared plus 6x at this moment, x equals 5. Notice we got just one x value. That's because we're looking at a particular moment, not a range between two x values. Remember to go over, let's just kind of quickly go over the graphical interpretation of that. So I've graphed that function here. I've drawn my secant line somewhere on there just to get started, just to show you. This is to get the theory in. Remember, the idea from our last video is the closer I bring this point to the point at 5, the closer the secant line mimics the tangent line. Okay, so the closer I get, the better the estimate will be for the tangent line. So I want to get really, really close. Okay, so look at my value to the left here. My value of that slope is negative 3.3 when I get close, negative 3.8, and then it's negative 4.3. I'm not sure what it's going to be. Okay, so this is why the algebraic interpretation is very nice. So I want to get points really close to 5. Okay, so what we do is we use our slope formula. We calculate with the slope formula, the average rate of change formula, but we pick 2 points real close to each other. We got to use 5, and we just pick something really close to 5. Okay, so I'm going to say let's let x1 be 5, and let's let x2 be something really close to 5. Like don't even pick 6. Pick really close. Like get right in there. So let's go 5.1. And what we want to do is find the slope between those 2 points, and that will be our first estimate. And I'll talk about what that means in a minute. Okay, so let's go average rate of change. That's going to be, here's my formula. Okay, and so I'm going to plug it in right away. There's my function. So I'm going to plug in 5.1 first. So I got negative 5.1 squared plus 6 times 5.1. And that's going to be my y value for 5.1. And then I'm going to subtract the y value at 5, so that's minus 5 squared plus 6 times 5. Okay, so there's my two y values, and I'm going to go x2 minus x1. So that's going to be 5.1 subtract 5. Okay, so I'm going to calculate this. Let's do that first part. So I'm going to go negative 5. Well, we had to use some brackets here, so clear all that out of there. So I got to go negative bracket 5.1 squared. Oh, I got to close that bracket. Alright, so we got that, and then we're going to add 6 times 5.1. So you could do that all in your calculator. This one's not the greatest for doing that, so I'm going to put negative 26.01. Now, when you're doing these, you want to keep lots of decimals. So if you could do it all in your calculator, if you can treat your calculator to get the right answer, then do it all in your calculator, because you want to keep as many decimals as you can. Now notice this is not rounded at all. That's the exact number there. So I'm going to write negative 26.01 down, negative 26.01, and then I'm going to add whatever I get there. So I'm going to go 5.1 times 6. So I'm going to 30.6. So I'll put 30.6. And you'll get to know how your calculator works. Alright, so then I can do this one. This is 25 and a negative. So it's a negative 25 plus 30. And this is all going to be over 5.1 minus 5. That's just 0.1. Okay, so let me punch that in. So this is going to be negative 26.01 plus 30.6, and that equals 4.59. And I'm going to subtract 5, and then divide all of that by 0.1. So we got 4.59 subtract 5 equals that. I'm going to divide that by 0.1. For negative 4.1. Okay, so that's my first estimate for my average rate of change. I got negative 4.1 for the slope of that secant line. Remember, it was a secant line we drew, or we calculated the rate of change. Now, to interpret it, look at that's negative. I got negative 4.1, but I don't know if that's close enough. Like I don't know if that's the right number, which is partly why we're doing estimates. Which means you have to do it again, okay? And here's the case. We keep getting closer algebraically, just like we did with the picture format, until we start repeating ourselves, okay? You want to do it. You keep doing it until you get accurate to 2 decimal places, which means as soon as you start repeating 2 decimal places, you can stop, okay? So which means we're going to do this again. This whole calculation is going to get done again, but we're going to get closer. I'm going to pick 5.01. And I hope to get something close to that so that I can stop. All right, so let's do it all over again. We're going to go average rate of change. I'm going to go, instead of negative 5.1, I'm going to put negative 5.01 squared plus 6 times 5.01. And then this is all the y value for that value. And we already know this value. We've done it already. We got negative 5, so I'm not even going to put it in there. Right? That's the same. We're still using 5. So I got 5 for the y value. And now I'm going to go 5.01 subtract 5. Okay, so break out my calculator. I'm going to try to do all this in one line. So I've got negative bracket 5.01 squared. I'm going to hit equals, and I'm going to add 6 times 5.01. Now my calculator can handle that. Notice it's typed all up in there. Okay, so I'm going to hit equals, and then I got that number, and I'm going to subtract 5 right away, and I get this number. Okay, let me write that in. So that's negative 0.040. Negative 0.04009. I'll write them all in, okay? 999, so that's really a 1 there, okay? And a 0. And I'm going to divide this by 5 subtract. That's 0.01. So when I divide that answer, 0.01, we get negative 4.01 by rounded 2 decimal places. Okay, so notice that's not exactly the same as this. So I need to do this one more time. Or maybe one more time, I'm hoping. So if I get another 0.1 in the next trial, then I can stop and say, look, this is really negative 4.01. And maybe it'll be 0.0. If it's 0.001, then it means I'm getting closer to 4. Right? So this decimal just keeps getting smaller, and I'd be getting closer to negative 4, and I then could stop and say it's really negative 4. So I'm going to do it one more time and get even closer. Okay, so we're going to use average rate of change. I'm going to go, it's negative 5.001 like this. Let's get it even closer like that. Squared plus 6 times 5.001. We know we're going to subtract 5 for the other value, and then this is 5.001 subtract 5. Okay, so I'm going to do all that again one more time to see if we get that right number. So I got negative plus 6 times 5.001. Hit equals. I got this number. I'm going to subtract 5 right away. I get that number, and I'm going to divide. Now this number is going to be 0.001. I'm just going to divide by that right now. Divide by 0.001. And notice I get negative 4.00009. And if I round, it's 0.000. That's a 9. Round it all out, that's going to be 0.1. Okay, notice if I did it again, I would probably get another 0 in there, which means everything is getting closer to 4. So I can say with accuracy that the slope of by estimating, the instantaneous rate of change is going to equal negative 4. That's how we do this algebraically. And notice I had to do it 3 calculations in order to make this work out. Sometimes it takes more. My recommendation is get real close right away. If I had gone from 5, instead of using 5.1 right away, I could have went right to 5.01, and I only really had to do it twice. Okay, so that's how we do average rate or instantaneous rate of change. Now you're going to practice.